Display devices. In display devices, LED will be seen first. LED, light emitting diode. So in light emitting diodes, we are going to cover introduction, history, construction, working, colors and material, types, comparison, application, and advantages and disadvantages. Introduction. Here LED is an acronym for light emitting diode. A light emitting diode is a 2 LED semiconductor light source. It is a PN junction diode which will emit light when activated by a suitable voltage applying to the 2 LEDs. History. The inventor of LED is in the year 1907. H.J. Round discovered electroluminescence when using silicon carbide and a cat whisker. He is from London and the United Kingdom. In 1920, Oleg V. Losev studied the phenomena of light-emitting diode in radio set. His first work on LEDs involved a report on light emission from Silicon, St. Petersburg from Russia. In 1961, James R. Beard, Bob Beard, and Gary Pittman developed the infrared LED at Texas Instrument. This was the first modern LED. He is from Dallas, Texas. In 1962, Nick Holoniak Jr. develops the red LED, the first LED of visible light. He used gallium arsenide phosphide on a gallium arsenide substrate, that is General Electric. He is from Syracuse, New York. In 1972, Herbert Maruska and Jacques Pankow developed the violet LED using magnesium doped gallium nitride film. He is from RCA Lab, New Jersey. In 1976, Thomas P. Pearsall developed special high brightness LED for fiber optic use. This improves communication technology worldwide. He is from Paris, France. Nobel Prize winner for the invention of efficient blue light emitting diode, which has enabled bright and energy-saving white light source. They are Isamu Akasaki, Nagoya University, Japan; Hiroshi Amano from Nagoya University, Japan; Suji Nakamura, University of California from Santa Barbara, USA. Now we are going to see the construction. So the LED consists of a chip of semiconductor material doped with the impurities to create a PN junction. The chips are mounted in a reflecting tray in order to increase the light output. The contacts are made on the cathode side by means of conductive adhesive and on the anode side with a gold wire to the lead frame. The plastic case encloses the chip area of the lead frame. So the anode and cathode in the LED is represented in this diagram. You can see in the diagram. Now we are going to see the N type of semiconductor which is used in the LED. So here this type of semiconductor is obtained when a pentavalent material like arsenic is added to pure silicon crystal. Each arsenic atom forms covalent bond with the surrounding 4 germanium atom with the help of 4 of its 5 electrons. The 5th electron is superfluous and is loosely bound to the arsenic atom. Next, p-type material. This type of semiconductor is obtained when a trivalent material like boron is added to pure silicon crystal. The 3 valence electron of boron atom form covalent bond with the 4 surrounding silicon atoms, but one bond is left incomplete and gives rise to a hole. Thus, boron, which is called an acceptor impurity, causes as many positive holes in a silicon crystal as there are boron atoms, thereby producing a p-type material. This is working of LED. How the working is done. in LED is represented in the diagram. Here, when we are applying the negative end of a circuit is hooked up to the N-type layer, and the positive end is hooked up with the P-type layer. Then electron and the holes start moving. If you try to run current the other way with the type P-type side connected to the negative end of the circuit and the N-type side connected to the positive end, current will not flow. No current flows across the junction because the holes under the electron are each moving in the wrong direction. So when the current flows across a diode, the negative electron moves in one way and the positive holes move in another way. The hole exists at a lower energy level than the free electrons. Therefore, when a free electron falls, it loses energy. This energy is emitted in the form of photon, which will be emitting the light. The color of the light is determined by the fall of the electron and hence the energy level of the photon. So this is the efficiency and operational parameter given for each and every color. So for red color, the wavelength range and efficiency is given. Red, orange, green, neon and blue. So for 5 color, they given wavelength range and typical efficiency, corresponding typical efficiency. Next, types of LED. LEDs are produced in a variety of shapes and size. The color of plastic lens is often the same as the actual color of the light emitted. So modern high power LEDs such as those used for lighting and backlighting are generally found in surface mount technology. Here some main types of LEDs are given. Traditional inorganic LED, multicolor LED, bicolor, tricolor, organic LED, miniature, high power. So first, traditional inorganic LED. This type of LED manufactured from inorganic material. Some of the more widely used are compound semiconductor such as aluminum gallium arsenide phosphide and many more. A multicolor LED, we are going to see bicolor. So here two different LED emitters that there are two types. One type will consist of two dyes which is connected to the same two color type of light. Here current will flow in one direction, will emit one color, and the current which flowing in opposite direction will emit the other color. The next organic light emitting diode. The OLED mostly used in display technology like computer monitor, television, mobile phone screen, etc. The semiconductor in an OLED is organic, which means it contains carbon. The OLED uses one of the two polymer or small molecules. Next, miniature. Miniature surface mount LED is available in most common sizes. They can be much smaller than a traditional 5 mm lamp type LED. So here are the few colors of miniature LED available. That is red, orange and yellow will be available in the range of 1.9 to 2.1 volt. Green and blue in the range of 3 to 3.5 volt. Violet, pink, purple and white colors will be available in the range of 2.9 to 4.2 voltage. Next, high power LED. For example, here CRWE XPG series LED achieved 105 in 2009, while Nichia released the 19 series with a typical efficiency of 140 milli per watts in 2010. These are the comparisons of LED with the CFL and the halogen. So here we compared the parameter life and lifespan, watts, cost per bulb, and then how much kilowatt per hour used for over the 25,000. The same way, for 25 hours, how many bulbs are needed or represented, and then cost of the LED bulb also represented. This is the information given by the USA government. These are the comparison view of the LED. Now applications. So LED uses fall into three main category. One is indicator and signal. Second one lightning. Third one data communication, and other signaling. So first indicator and signaling. The low energy consumption, low maintenance and small size of LED has LED to uses as status indicator and display on a variety of equipment and installation. These are used as stadium, airport, and the railway station, train, buses, trams and ferries, etc. So lighting LEDs are now most commonly used in all market area from commercial to home use. That is standard lighting, stage, theatrical, architectural, public installation, and wherever artificial light is used, you are using LEDs. These are few lighting LED, home touch, home light bulb, etc. Now, data communication and other signaling application. Here, light can be used to transmit data and analog signal. Listening devices in many theaters and similar spaces uses array of infrared LED to send sound to listener receiver. Light emitting diodes are used to send data over many types of fiber optic cable, from digital audio, the very high bandwidth fiber link that form the internet backbone. Now we are going to see the advantages and disadvantages. See, if you look at the advantages, means efficiency play an important role. That is, the LED emit more lumens per watt than the incandescent light bulb. The efficiency of LED lighting fixtures is not affected by shape and size, unlike the fluorescent light bulb or tubes. Color LED can emit light of an intended color without using any color filter, as traditional lighting methods need. Here, many colors are easily available. Size LED will be very, very small, that is smaller than 2 mm. On off time is very quick in LED. A typical red indicator LED will achieve full brightness in under a microsecond. And cycling of LED also very ideal for users subject to frequent on and off cycling, unlike incandescent and fluorescent lamp that fail faster when high intensity discharge lamp that require a long time before restarting. The lifetime of LED can have a relatively long useful life. One report estimates 35,000 to 50,000 hours of useful life, though time to complete failure may be longer. Focus. The solid packages of the LED can be designed to focus its light. Incandescent and fluorescent sources often require an external reflector to collect light and direct it in a usable manner. Then high initial price. Before in the 2012, the cost per 1000 lumens is about $6, but in 2013 it was $2. In March 2014, $1. So LED play more expensive for price per lumen. Then light quality. Most cool white LED have spectra that differ significant from a black body radiator, like the sun or an instant light. Temperature dependence. Driving the LED hot in high ambient temperature may result to overheating of the LED package, eventually leading to device failure. Then voltage sensitivity, non-reparation. Thank you.